Well, hello. Welcome to today's video in which we are continuously exploring the world of fractions. Today, we're going to be talking about fraction of and how we look at that as an area model or really an array. This is again how we're thinking about multiplication with fractions and really how we make sense of the why, right? We're kind of getting the how. Like we've had a few things that kind of help us think about the how. Now we want to kind of dive in deeper to understand why this really happens the way that it happens. So a couple of things as always, again, right? That keyword that we look for a lot of times when we see this in a story problem or a word problem, depending on what you want to call that, is of tends to bring my brain towards multiplication. And we're again thinking about fractions. So we're just talking about fractions, not top heavy, not mixed numbers, but fractions itself, which means we have items that are smaller than one. And then again, how we can kind of do this with this concept of an area model, like how we show what's really happening. And one thing that we like to talk a lot about is area model and array. They kind of go together. Well, they don't kind of. I don't know why I would say kind of. They do go together. They are the same thing because it's this concept of rows and columns. So let's dive in today and kind of talk about what this means. So the first problem that would come up is a lot of times you see this kind of things. Like the question might be like, what is 1/5 of 20, right? So typical question that comes across in 5th grade math, 1/5 of 20. What is 1/5 of 20? Cool. Well, let's talk about what we really understand that to mean, right? We are talking about multiplication. And if we're talking about multiplication, then we can symbolize this in the form of an array, right? Something that shows this idea of rows and columns, right? So rows go left and right, columns go up and down. So how do we fit this into the model? Well, the first thing I need to understand is that my total, right? My total array is going to be 20. That's my largest value here, right? I'm taking 20 and I want to know what is 1/5 of it. So let's kind of break apart what that means. One, I know that the total area, right? Array, area model in here, right? This total in here. Oh, why would I do that? Let's just do it this way. My total in here, right? Rows and columns would be 20 squares. This is not 20 squares, but what we do understand is that I would need 20 squares inside this. Now, if we now think about, okay, well, that means that somehow I'm going to need some amount of rows times some amount of columns to equal 20. Well, what else do I know and what can I build off of? And that is such the cool thing about math is we often just think about, well, what do I already know and what can I build off of? Well, one thing I already know, is that I didn't want to erase that. One thing I already know is that according to my denominator, we're talking about groups of 5, right? We're talking about groups of 5. So that actually means that one side of my array, my rows or my columns can be 5. It doesn't matter which one, because again, remember that commutative property of multiplication doesn't matter the order. So I tell you what, let's just make our rows 5. So that's what I'm going to do. I'm going to take this out and I'm going to symbolize here that I have 5 rows and I'm actually going to draw 5 rows, right? So one of the tricks there is I'm going to draw 4 equal parts. I like that. Let's make it a little bit smaller. Let's try that again. 1, 2, 3, 4. Oh gosh. Okay, cool. And what that really then shows me here is I have 1, 2, 3, 4, 5 rows. Cool, right? Thank you, denominator. We said in the very beginning of fractions, denominator is one of your best friends. It's going to tell you so many things. Now, the other thing we know then is that this total piece, all the squares together, is going to get me 20. Well, that basically means I have 5 rows times some amount of columns to equal 20. Well, if you're out there screaming at the video right now, you're saying, oh, it's 4, right? Which is true. 5 times 4 gets me to 20. So I'm going to now take and cut my rows into 4 equal parts. And I can even label that up here. I'm going to do that, not even kinda. I will actually do that. And now we have this array that actually represents the 20, right? We know it's groups of 5, so we have 5 rows by 4 columns. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 there. Now, the cool part about how we can figure this out mathematically is that, well, what we're looking at, according to our fraction here, is that we actually want one of these 5 rows. So if I actually just shaded in one of these 5 rows, I can see that 1/5 of 20 is equal to 1, 2, 3, 4. Now, I know that's a lot, right? So again, what's really important is we start to understand like why this is happening and what it means. And if we look at it, what we're saying here is we took 20 units and technically, because fractions are like division, we kind of put them in 5 groups and then we just took one of those groups. Now, I can understand if that's still feeling a little confusing, but if we talk about like what we did yesterday, so I'm going to jump pages, but I'm going to keep the same problem, 1 of 20, right? Well, what we did yesterday, well, we know 1 is multiplication, so that's 1/5 times 20. And we were talking about, okay, well, I could sit here and write out 1/5 20 times. Or I can just say, oh, well, 1 times 20 is 20. My denominator doesn't change. This is a division problem. So 20 being divided by 5, 5 times 4 equals 20. So this is equal to 4. So 1/5 times 20 is 4. And you'll see here, that's the exact same thing we got. And this is kind of the why. Like what we start to explore here is this strange world once again, where this time in math, I'm taking 20, and when I multiply it, I actually end up with a smaller result. I'm multiplying and things are getting smaller. And again, if you look at that model, that makes sense. I had 20 units, but by multiplying it by 1/5, by putting it into this 5 groups and just taking one of the groups, I actually only end up with 4. And so my value gets smaller. 1/5 of 20 is actually smaller than 4. And that does make sense because again, if I had 20 students in a class, right? Let's say there's 20 students in a classroom and only 1/5 of them came to school. Well, then that means only 4 students are at school. It's not all of them, right? If I had 5 out of 5 students or 5/5 of those students coming, well, that would be all 20 of them. But we'll get more into that later. So I hope this is starting to sink in a little bit. It's complex, so don't worry if you're already like, what? Right? Because part of it is exploring and thinking. And of course, the other part is let's just keep practicing these to see how this makes more sense. So let's take another problem. Again, we're using that fraction of, so we have 1/3 of 18. And so again, the first thing I want to do is think, all right, well, of is multiplication, and multiplication is area, and area is an array. And if I look at my denominator, it tells me, right, that one of my numbers, something times something, is going to equal 18. Well, one of my numbers is 3. So again, I can have 3 rows. And I can think there, okay, well, 3 times what equals 18? Well, let's see here. 3, 6, 9, 12, 15, 18. So 1, 2, 3, 4, 5, 6. Okay. Which means now I'm going to cut my rows into 6 pieces. One, 2, 3, 4, 5, 6. Cool. And then I want to think about, all right, well, I want 1/3 of this. So I want one of the 3s. So remember, this is the rows are the 3. So I want 1 row. 1, 2, 3, 4, 5, 6. Oh. So 1/3 of 18 is equal to 6. And again, it is smaller. If I had $18 and I spent 1/3 of it on something, then that means I spent $6. And again, we can look at this mathematically, right? Again, this is the how, this is the why, like why it happens the way it is. But the how that we've talked about is, whoa, well, 1/3 of 18 is the same thing as 1/3. 1/3, I'm getting there. There we go. Times 18, right? So 1 times 18 is 18. The denominator stays the same. 18 divided by 3 is equal to 6. So mathematically, it comes out 2. So again, this is over here, this model is the y, and down here is just kind of how we do it. So let's try another one, because we love that. So let's do another one at this point. What if we took 1/2 of 6? Now, you might already be able to figure that one out if you think about cutting something in half. But again, let's just think about how this looks in a model. So of is going to mean we're going to multiply. If we're going to multiply, then I'm using an array. An array is made of rows and columns. My denominator is one of those. This time, let's make it our columns this time, because it does not matter. So boom. And this is again telling me that 2 times something is going to get me to 6. Well, that's going to be 2 times 3. So I'm just going to that. And if I count, right, I should have 6 blocks. 1, 2, 3, 4, 5, 6. And then in this case, we want one of the 2's. So that's actually one of my 2. So here's one column, which is actually equal to 3 pieces. 1/2 of 6 is equal to 3. Whew, okay. Let's just do one more, because let's take it to like a higher complex level, as we kind of, right now we're just using unit fractions. Right. But again, if we want to think about what this means, right? If I have 6 people and I decided that I wanted to put them into teams, well, one of those 2 teams has 3 people on it. That might help. I could also say I have 6 donuts and I have 2 containers. One of those 2 containers has 3 in it. In fact, that's 3 as well, because it's equal. Okay, sorry. I can never resist to kind of think about what does this really mean. So I apologize. That's why. So what I was talking about here now is like, what happens if we don't have a unit fraction? What if someone's like, oh, okay, well, what about 2/6 of 24? Well, guess what? The rules don't change, right? That's that thing we want to keep remembering. The rules just don't change. So again, so I'm thinking multiplication. If I'm thinking multiplication, I'm thinking array. If I'm thinking array, I'm thinking rows times columns, because that gets me my area. We know my area is 24, so the total is going to be 24. And right now, the gift that they're giving us is one of these, the rows or the column is 6. So I don't know, let's do the column again this time. It doesn't matter, right? This time I'll just say, oh, it's a column. So let's cut this array into 6 columns. So I'm going to start, I'm going to take half of each one of those, and that gets me 6. 1, 2, 3, 4, 5, 6. Well, if I know the whole thing's supposed to be 24, then I'm really thinking about 6 times what equals 24. And if I don't know that, I can skip count by 6s till I get to 24. So 6, 12, 18. So that's 1, 2, 3, 4. Which means now I need 4 rows. 1, 2, 3, and then 1, 2, 3, 4 rows. Okay, so there's my array. 4 rows, 6 columns, 24 boxes total. But now I want the fraction of that. And what I actually want to make sense of is how much is 2 of these columns? Well, here's one column, and here's the second column. And so if I was to count all that out to find my answer, I'd say, oh, that's 2, 3, 4, 5, 6, 7, 8. Oh, well, 2/6 of 24 equals 8. So I'm just pausing and kind of letting that sink in as we kind of look at that and think about, wow, okay, like what am I doing here and what are my steps? And of course, we're going to continue to practice these. So I don't want you to stress it or freak out, because it's okay to confusing, right? That's why we want to ask questions. We want to explore. We want to play around. We want to think about, what do we know about numbers and how do they relate, right? What is that relationship, that inverse, multiplication and division? So let's also then just finalize this today. I'm not going to do another problem, but what we'll do is let's take this and kind of do the how. Right? This is again the why. Why does it happen? But here's the how, right? What we've learned is 2/6 of 24. What we've learned in class is when we're multiplying those fractions in a whole number, right? Of just means multiply. And then up here, I'm really thinking about, oh, well, I have 24 holes. In each hole, I have 2 of those pieces. Times 24 is 48. So I have 48 pieces out of 6 because 6 make up the whole. So now that's just a division problem because I have an improper fraction or a top-heavy fraction. Well, that 48 divided by 6, that equals 8. I actually know that math fact. 6 times 8 is 48. So my answer is 8. 2/6 of 24 is 8. 6 times 24 equals 8. Well, what do you know? That's what we got here as well. So I'm going to leave us right here on this one as you can kind of stare and look and think about, again, what did we do and what are effects and how did our denominator come in handy today? And I'm just going to leave it at that. I want to thank you for your hard work and do not stop asking questions and do not stop learning from mistakes. That is the best way we're going to do this math. And we appreciate you. And as always, we will see you next time.